Okay, slightly more general example this time. So we're starting off the same. So we're showing that the above is true. So working right to left, if I want a common denominator of r plus 1, r plus 2, I'm basically multiplying these three together. So top and bottom of the first one by r plus 1, r plus 2. I need to multiply top and bottom of the second one by r plus 2, and then multiply top and bottom of the third fraction by r plus 1, and then I have a common denominator of r plus 1, r plus 2. We will link these in with partial fractions in a lesson or two, so you can sort of see there's a natural link there where you go that way instead. So hopefully you've all done those. Tidying this up, I get 2r squared plus 2r plus 3r plus 6r plus 4. Obviously be careful with signs around here because it's minus all of this. So it's minus 3r squared minus 6r plus r squared plus r. And then tidying that up, obviously just check it works. So 2r squared plus r squared minus 3r squared, they're all going. 6r minus 6r, they're cancelling off, and I'm left with r plus 4. Like so. Moving on from there, we want to use method of differences to sum a series. And this is a more general series, so it's finishing on n rather than on a specific number, but the method is the same. So it's hence, so we want to use what we found. And so this sum here is equal to the expression we found in part A. So it's 2 over r minus 3 over r plus 1 plus 1 over r plus 2. I should really bracket that just to show that we're summing the whole of that and not just 2 over r. Same method, so the first term is equal to 2 minus 3 over 2 plus 1 over 3. Second term, substituting in r equals 2. 2 over 2 is 1 minus 3 over 3 plus 1 over 4. Nothing obvious happening yet in terms of how they're going to cancel off, so I've got to go to a third term. 2 over 3 minus 3 over 4 plus 1 over 5. And then if you look at what's happening, I've got minus 3 over 3. I wouldn't cancel these fractions down particularly with this because you can sort of see what's happening easier without that sometimes. But minus 3 over 3 plus 1 over 3 plus 2 over 3 is obviously 0, so they're all cancelling off. You could chuck another term in if you wanted to see it a bit more clearly. So I've got 2 over 4 minus 3 over 5 plus 1 over 6. But you can just see this pattern's going to continue. So cancelling down like that. So a quarter minus 3/4 plus 2/4 is 0 as well. So if I put in the last two terms, this time they're going to be in terms of n. So un minus 1, sorry, not plus, is equal to 2 over n minus 1 minus, so I'm putting n minus 1 into here. n minus 1 plus 1 is n. And then n minus 1 plus 2 is n plus 1. And then the last term, I'm letting r equal n. Which takes me to there, cancelling down. So that's cancelling with that, that's going with that, that's going to go with one that's sitting in here, but you can just actually take it down to here, if you think about it. And then that one will go with 2, so these two will have 1 above it, which cancel it off. That one will have 2 above it on a diagonal, which will cancel off. And then you're left with the 3 terms at the beginning. So you're left with these ones here and the 3 terms at the end. Don't forget to include their sign as well. So the sum required, being lazy, is equal to 2 minus 3 over 2 plus 1 plus 1 over n plus 1 minus 3 over n plus 1 plus 1 over n plus 2. I just move that board over in case you need it. So sorting the numbers out, we've got 2 plus 1 is 3, minus 3 over 2 is 3 over 2. I've got 1 over n plus 1 minus 3 over n plus 1, so it gives me minus 2 over n plus 1 plus 1 over n plus 2. You don't need to combine them together into one fraction unless the question asks you to. So that's the sum from r equals 1 to n of this. And then you can obviously use this to find specific values of that sum. So for instance, I might squeeze this onto this board actually. I'll pop it up here in a different colour. So if you want the sum from r equals 1 to 20 of r plus 4 over r plus 1, r plus 2, then I can just substitute in n equals 20 into this result now. So that's equal to 3 over 2 minus 2 over 21 plus 1 over 22. So that's kind of part C. And you can just pop that into calculator. So that gives you 335 over 231. And particularly in an exam, that's not a bad answer to check, because if you've got that right, then you can assume that you've got the whole question right as well. So we're getting to some results for sums in terms of n with this method.